Today's lesson is section 1.6, and we're going to be looking at two-dimensional figures. So we're just going to do the basics of two-dimensional figures today. There are several key concepts and definitions, so let's go ahead and get started. So a polygon, if you look at the image, the key concept box down here, it says a polygon is a closed figure formed by a finite number of coplanar segments such that. So these are going to be different things that a polygon must contain. It says the sides have a common endpoint, are non-collinear, and each side intersects exactly two other sides, but only at their endpoints. So with those two stipulations being there, let's take a look at the examples and non-examples. So examples, when they're closed, that is a key that it's going to be a polygon. So meaning all of the sides meet. There are no gaping holes in it like that first non-example. Right? So everything has to have an endpoint and match up. The other piece is that it cannot have any rounded edges. So in that non-example, notice how all the examples to the left, none of them contain round edges such as a circle or a semicircle. And the last thing is that the points cannot be inside one another. So notice how this last figure, we cannot count that as a polygon as one entire figure. Now we could say LM and that one, that makes a triangle, so that would be it. So each of these little separate figures could be polygons, but the entire figure together cannot be a polygon because they meet there at that intersection point. All right, it says a polygon is named by the letters of its vertices written in alphabetical order. So they do give those examples down here. So the first one is ABC, the second is WXYZ, and the third is EFGHJ, K. Okay, they left out I because it sort of looks like a 1. All right, so basic information, we'll come back to that in a little bit as well. Convex. So it says it's a polygon for which there's no line that contains a side, and a point in the interior of the polygon. Okay? All right, so concave is a polygon for which there is a line that contains a side and a point in the interior. So let me draw two pictures here. All right, they're not going to be the best pictures, so we'll do a basic triangle first of all. Okay, so let's do a basic triangle. You know what, since I'm in Word, I bet I can even insert shapes. Let's do that because it'll make my next one so much better. Hang on, I want shapes. Look at all these great shapes I could have picked. All right, the other one I was looking for was a star. There's no stars there, so that's okay. I'll just go back to drawing them. Okay, and now you can just see my best attempt at a star this manner. All right, so not perfect. I was going to say not terrible, but it's pretty bad. But anyways, here's our star. So let's look at this. All right, we'll use the red magic pen. So convex, it says there's no line that contains a side and a point in the interior of the polygon. So meaning if we are to extend every side of this, these extension lines will not go on the inside of the figure. So see how I extend every single side and it does not mess up anything on the inside. There's no points. So let's try the same. So that means that one is convex. Let's try the same thing with the star. So if I extend even just this first side of the star, do you notice how there are parts of that line containing points inside the figure? As soon as you see those lines inside the figure, you know it is concave. The way I like to remember that is you can go in a cave, you can go inside a cave, so that means there are points inside. All right, biggest difference between the two. An n-gon, it's a polygon, should be an O in there, with n number of sides. All right, a regular polygon is a convex polygon with all sides congruent and all angles congruent. Perimeter, it says the sum of the lengths of the sides of a polygon, so we're adding up all the sides. Add up all the sides, that's perimeter. Circumference is the distance around a circle. So you can sort of think of it as the perimeter of a circle, but since the definition for perimeter says a polygon, circle is not a polygon, they can't put it like that. So just think of circumference as the perimeter of the circle. And area, it's the number of square units needed to cover the surface area. So I always think of that if you want to cover something up or lay a rug down on a floor. You need to know how big of an area you need, how much square footage is on your floor, so square feet area that you want to cover. All right, let's take a look at example 1. It says name the polygon by the number of sides, then classify it as convex, concave, regular, or irregular. Check back to this day's folder. I will put in there, write myself a note, to put in there the names of different shapes up to, I'd say maybe 10. And that's also something you could look up, but just so we have it, okay? All right, so this first one, it has, I'm gonna number them, 1, 2, 3, 4 sides. So anything that has 4 sides is called a quadrilateral. All right, classified as convex or concave. Well, if I extend all the sides, you don't have to extend them forever. Great, none went on the inside, so that must mean that it is convex. And then regular or irregular. So if you go back up here, remember, regular means all sides congruent and all angles congruent. Well, they didn't tell us anything about the angles, but let's look at the sides. Well, this side has 1 tick mark, that one has 2. So already that means those 2 sides are not congruent. So we're going to write irregular. All right, let's do the same for this next figure. All right, I'm going to start here and I'm going to put 1, 2, 3, 4, 5, 6, 7, 8. This one has 9 sides. A nine-sided figure is called a nonagon. All right, now is it concave or convex? So I'm going to start with my side 1. That looks good so far, didn't go on the inside. Let's do side 2. If I continue that straight line, it does go inside, so we're going to say concave. And then I can see some of the sides are the same, but the definition says they all have to be the same, so therefore it is irregular. All right, example 2, find the perimeter and the area for the figure. All right, so this appears to be a rectangle, and the reason we're going to know some of this stuff, and we'll get into all of this when we have our information on polygons, is that it has 4 congruent sides. So it's a basic shape that you guys have probably learned about way back in elementary school. So since it's a rectangle, 4 perpendicular angles, I should say, 4 90-degree angles, opposite sides are the same. So this left side is 2.3 centimeters and the top is 4.6 centimeters. So to find the perimeter, we have to add up all the sides. And if you do forget the perimeter, there are formulas for this on your formula sheet for different shapes. So 4.6, there's 2 of them, so I'm going to multiply that by 2, plus 2.3, and there's also 2 of them, so I'm going to multiply those by 2. So we get 9.2 plus 4.6, so the perimeter of this shape is 13.8 centimeters. Okay, and now we get to find the area. So for area, we use the letter A. All right, so for area, and again, you can look this formula up on your formula sheet if you need to, but a rectangle, square, they have the same area, which is length times width. So the length is 4.6 times the width is 2.3. And if you multiply 4.6 times 2.3, you get the area is 10.58 centimeters squared. Okay, it is super important that you guys put the units on this, because if you put 10.58 squared, that is not correct. If you do 10.58, and some people do this because they do square centimeters, that's not right because that squared is still next to the number, meaning I need to multiply it by itself. Okay, so please be careful with that. So there you have area and perimeter. All right, but not every shape is a polygon. So let's take a look at example 2, where we have to find the circumference and area of the circle. All right, so the formula for circumference, again, on your formula sheet, it is 2 pi r, or you could do pi d, because the radius, 2 of the radius is equal to the diameter. I'm going to use this formula because they gave me the radius in the problem. So substitute in what you know, circumference, that's what we're trying to find. 2 times pi times my radius, which is 4. So I'm going to do 8 pi. If they asked you for an exact answer, you would need to leave it as 8 pi inches. I know that doesn't look to be exact, but the reason it's exact is because if you were to put the pi symbol in your calculator, it would give you a value, pretty long value, but not the actual value of pi, because if you remember, pi goes on forever. So there's no way that we can actually find a 100% true answer. So that's why this is considered an exact answer. If we wanted an estimate, just take your calculator, type in 8 pi, and we get that it is approximately, it's a symbol for approximately, 25.13 inches. Just to give you an idea of how long a string you might need if you're trying to put a string around this. Right, circumference, done. Now let's take a look at area. The area of a circle is pi times the radius squared. So I'm going to take pi times the radius is 4 squared. So we get 16 pi inches squared. Remember, anytime we look at area, it's in square units. But if we wanted an exact answer, we would get the area is approximately 50.27 inches squared, or square inches. All right. Moving on to example 3, a multiple choice question. And then I think we just have example 4, which is going to take us a little bit of work. So let's get on to example 3. It says Terry has 19 feet of tape to make an area in the classroom where the students can read. Which of these shapes has a perimeter that will work? All right, she has 19 feet of tape, so that's all the more tape she has to make this perimeter. So we have to look at this. So this is probably going to be like 4 mini problems in one. So it says a square with a side length of 5. So if we want perimeter, that means we would have to do, it's a square, so 5 plus 5 plus 5 plus 5, or you could take 5 times 4, which is 20 feet. Well, she only has 19 feet, so we're going to be short, so it's not A. B, it says a circle with radius 3 feet, so perimeter, 2 pi r. So that means C is equal to 2 times pi times 3, which is 6 pi. And if I take 6 times pi, we get 18.8, I'll do 85 feet to round it correctly. Let me fix that 5. All right, so that one appears to work. But we're going to be good students, so we're going to go through C and D just in case I accidentally made a mistake. So a right triangle with each leg 6 feet. So if I have a right triangle, each leg is 6 feet. The formula for perimeter of a triangle, good thing we did Pythagorean theorem the other day. So to find the perimeter, we're going to have to use Pythagorean theorem to find that third side. So I'm going to do 6 squared plus 6 squared equals z squared. So I get 36 plus 36, and we get c is equal to the square root of 72, which is approximately 8.5. We'll just do 8.5. So now to find the perimeter, we have to do 6 plus 8.5. So 12 plus 8.5. We already know that's going to be bigger. So that is 20.5. We only have 19. Can't do that. And D, it says a rectangle with a length of 8 feet and a width of 3 feet. So we could do perimeter is 2 times 8 plus 2 times 3. So we get 16 plus 6. That's already too big. We get 22 feet, which is too much. So it does appear that B was our correct answer. All right, so don't forget, at any point, you are more than welcome to pause the video to catch up if I'm going too fast for you. That is one nice thing. Always look for the positives. One nice thing of having the videos. All right, example 4. It says, find the perimeter of a pentagon ABCDE with those vertices. Now, this problem gave us all of the ordered pairs, and they gave us the figure. I am so happy for this figure right now because I'm looking at it, and I know that if we're trying to find the perimeter, that means I have to find the length of all of these sides. So if they're not vertical, horizontal, distance formula. So we're going to have to do distance for E to A. Distance for A to B. B to C, we have to do distance, but look at the last two. C to D, we can just count. So 1, 2, 3, 4, 5, 6 units long. And this one is 1, 2, 3, 4, 5 units long. So that already cut our work down just a little bit. We still have to do distance for the other ones. All right, so let's take a look from A to E. Remember, try to keep your work organized. So the ordered pairs are 0, 4, and E is -3, 1. All right, so do distance formula. So we're going to do -3 minus 0 squared plus 1 minus 4 squared. So I'm going to get 9 plus 16. So we get the square root of 25. I'm lying to you. I forgot 1 minus 4 is -3. And -3 squared is 9. So 9 plus 9 is 18. There we go. That looks a little bit better. I'm going to go ahead and put approximately what these decimals are. It might make it easier to add later. So 4.24 units. Okay, A to E done. 2 more to go. Let's do A to B next. So the coordinates of A to B are 0, 4, and 4, 0. So x1, y1, x sub 2, y sub 2. So distance is equal to 4 minus 0 squared plus 0 minus 4 squared. So we get 16 plus 16. So we get the square root of 32. And if we substitute that into the calculator, it's 5.66 units. Okay, I'm going to underline these so I don't forget where they are. All right, one more side. All right, the last side we have to do is B to C. So the coordinates of B are 4, 0, and the coordinates of C are 3, -4. So x1, y1, x sub 2, y sub 2. So we have 3 minus 4 quantity squared plus -4 minus 0 quantity squared. Don't forget your square root. So we get -1 squared, which is +1. -4 squared, which is +16. Don't forget your square root. We get the square root of 17, which is approximately 4.12. All right. We're not done, though, but we're almost done. All right, so perimeter of this pentagon. We have to add up all the sides. So that's going to be 4.24 plus 5.66 plus 4.12. But then don't forget these two guys up here, plus 6 plus 5. All right, so type them in the calculator, do all that good work, and you get approximately 25.0 O2 units because we don't know the units. So even though that problem required us to complete a lot of work, it's not difficult. I understand it does get tedious, so I'll try not to give you problems with like a 100-sided figure, but do show your work when possible and make sure you count accurately on the picture.